Hey, good morning, everyone. Good morning.
Good morning, Professor.
Hey, good morning, Devin. Excuse me. My voice is not uh, at its best this morning. All right, so good morning, everyone. It looks like I have, I'm just, two more people. Okay, so I got 12 people currently. In the collaborate, and let's go to the forum and see how many are there.
Good morning, Professor.
Hey, good morning, good morning. It looks like I have 14 people in the in today's forum, and 12 in the collaborate. So two more people need to catch up, and hopefully the rest of the class will join us shortly. So today we're moving on to the next topic, right? We have already moved on to this already a long time ago. Actually, we are through, right? Actually, by the main lecture, we are done with this topic by the main lecture, and everything is grayed out. That means you should be caught up all the way. Uh, all you should be caught up all the way. I mean, there are how many videos are there? Actually, it's like 2, 4, 6, 8, 10, 12, like 14 videos, right? Which is worth like 7 hours, right? Each video being 30 minutes long. So if you don't see this anymore, then that means you gotta go to my YouTube channel. And let me just quickly check if so today actually you should be able to go into I mean this is already topic 4 by the main lecture. Topic 4 is already starting. It must have started already because I have so many videos. I believe 6 videos. That's 1, 2, 4, 6. Yeah. So that's actually by today you should be, or by the coming week you should be caught up with all of these, right? Um, but we are in topic 3, and topic 3, although it is the title managing bond portfolio, but it is actually about duration and convexity. It's about duration and convexity. So it's about duration and convexity. So what is duration? Now, duration sounds like it's the length of time, right? In other words, the maturity, but it's different from maturity. It's not maturity. It's quite different from maturity. Um, why? Okay, maturity is usually uppercase T, right? And usually, of course, duration is less than maturity, and it will at best it will be equal to maturity. Okay, it will be equal to maturity. And so what does that mean? You can think of it this way. I mean, to put it in a simple, uh, let's go to in the slide. Duration is effective maturity, meaning, it's the weighted average. Weighted average of the periods until, so how should I, until each payment with weights proportional to the present value of payment. So take a look at the math. Duration is basically, weight of each time period, right? Which is determined by the present value of each payment out of the entire bond price. Okay, so the formula is like, think about it. Duration is a time. Duration is time. But the time, if we think about time, then you might think about the maturity. I mean, if the bond has 3-year maturity, then, the bonds, it will take 3 years, for the bond to mature. But if you think about, but that's only on the surface. And if you think about the effect of the present value of each payment. Now think about it. In bond payment, in bond, the cash flow is basically the coupon payment, right? So there will be 3 coupon payments at the end of year 1. I mean, if we assume annual coupon, right? And just to make it simple, just to simplify our thought experiment, we'll assume annual coupon. So if the maturity is 3 years, if t is 3, we know there will be 3, the present value of the bond, right? The bond price. We all know it depends on, we can calculate it. It's present value of annuities plus present value of the face value. But then, what that means, coupon payment, what should I? So I'll just call it cash flow, right? Coupon payment 1. We have to discount it. Coupon payment 2. We have to discount it. And Y being the yield to maturity, right? Yield, which is the discount rate, basically. And the coupon payment 3, discounted 3 times. And then finally, the face value, right? So then think about it. What is the and suppose the Y is something like 10%, right? What would be the effect of all these future cash flows to the price of the bond today? Obviously, this one will have the most effect, right? The earlier payment, earlier cash flow will have the most impact because it is discounted the least, right? And then the second one will have less impact on the present value. Third one will have less impact than the second one, which is even less than And especially, think about it. If the discount rate is that something like 10%, which is very huge discount rate, right? The further into the future, right? The further this way you go, it gets discounted more, right? It gets discounted deeply. And especially, think about it. It's unlikely, but let's say coupon rate is something like 15%, very high coupon rate, right? Or 20% coupon rate. And the longer the maturity, right? The effect of the present values of all the coupons, the effect of present value of these annuities is greater than, right, the effect of the present value of the face value. The longer the maturity, right? If the maturity is short, of course, the present value of only these three payments cannot be greater than the present value of the $1,000 par value, right? But the longer the maturity, right? And if you think about it, because the impact of the earlier payments have more impact on the price of the bond, right? After a certain number of years, right? You have already collected most of the cash flow. Suppose the something like what if maturity is something like 20 years, right? Not 3 years. Then because the later coupon payments will be discounted a lot, the present value of later payments won't have much impact on the price of the bond anymore. In other words, most of the coupon payments, most of the present value of the coupon payments, you will have already harvested all of it, right? Harvested most of it, probably by year 15, right? So in other words, you can say effectively, the maturity is almost like 15 years. If the if the bond has longer maturity, right? Longer maturity, and if the bond has high discount rate, right? Because the longer into the future, the far away coupon payments will be discounted a lot. So it will have very minimal. It will have minimal impact on the price of the bond. So effectively, the maturity will be shorter, right? So that's basically the concept of duration, effective maturity. Okay, so let's take a look at this example, right? I mean, to make it easier to understand, I want you to download, of course, you need to download everything, right? But most of all, spreadsheet 11-1, okay? Download this, spreadsheet 11-1. And I'm not sure if this is, it's the same thing that we used before, but I guess No, no, don't download this because this one it will need to be. So I'm gonna. Okay. Never mind. I'm gonna do this later. So what does it say? Item is available, but some students or group may not have access. Okay, so never mind. But let's do this. If you have downloaded this, right? Okay. Alrighty, you will see. You will have just one spread, one worksheet. Did you all download this? Everyone? Are you there?
Yes.
Anyone?
Which one, Professor? Yes, we are here.
Spreadsheet 11-1.
Cool.
Okay. Yeah.
Yep.
Here. Okay. Let me. So this one, spreadsheet 11-1, right? Please download it, and you need to have it right in front of you, right? Do you have it now? Do you have it in front of you?
Yes.
All right. So let's do this example. So this example, obviously, it has maturity of 3 years, right? This bond has maturity of 3 years, and it looks like the coupon rate is 8%. Coupon rate is 8%. How do I know? Well, because each year the payment, coupon payment is 80. It's given. So if I would, if I were to make this example, I would do it like this. And then, right, use that to give payment here, right? But anyway, it was already, given like this. So at the end of year one, the coupon payment, $80, right? Probably I'll put dollar. It doesn't matter. At the end of the second year, $80. And at the end of the third year, $80 plus 1,000, face value, par value of the bond, right? But the present value, right? This column is present value. And to find present value, it's not a difficult thing. We just need to divide that by 1 plus the interest rate, or the discount, that's the discount rate, and you're gonna lock it, right? Then you raise it to the year's digit, and that way you can just drag it down. We'll drag it down, right? So think about it. this is not this is only for 3 years. So still, the what affects the okay, and then we need to if we sum all of this, that's the price of the bond, right? That's the rational price of the bond. So using auto sum, right? Now, of course, the price is mostly affected by the par value, right? The present value of the par value, right? The face value. But because it is only 3 years, but if you have like 10 years, if our timeline is something like 10 years, 20 years, then the present value of the face value or the par value won't be that much. It will be, because it's discounted like discounted 20 years back, right? And obviously most of its price is derived from the earlier payments, right? Present value of earlier payments. And then so the impact on the price would be earlier payments, which are discounted less. And most of the if this is a 20-year bond, most of the value of the bond is derived from the earlier years. So effectively, you will have already collected all the payments, all the cash flows in an earlier time. Not until, you don't have to wait until year 20, but by year 15, 16, you will have already collected all of its cash flows, right? But what we want to do here is, so what is the weight of the earlier payments? What is the weight of the earlier payments? Right? What is the weight of the earlier payments? And the late, of course, the weight of the earlier payments would be greater, right? And so the weight will be that divided by, so the present value, the earlier payments, present value of the earlier payments out of the total value of the bond, the price of the bond. So I'm dividing it by this, and you will need to lock it again because you're gonna drag it down. So you'll drag it down. And then by adding up, it will have to add up to 1, right? So, and then, okay, bottom. Then the weighted average, right? We'll find the weighted average of that, weighted average, right? So what is the weighted meaning, weighted importance of the year 1, right? It's actually year 1 is actually like, of course, that's exactly, like that. And then what's the weight of year 2? What's the weight of year 3? And then once you found the weighted values of year 1 through 3, and then of course you sum it all, right? You sum all of it. Then what do you see? 2.777. So what is that? That's the duration. That's the duration. Okay. That means effective maturity is not 3 years, but 2.77 years.
Professor,
Yeah,
I'm sorry, what did you do in column E? What did you multiply?
column E.
I mean, no, like the F, where it says column E. Oh, you multiplied column B times column, okay.
You mean column F?
Yeah.
You're asking for column F?
I mean, but I
Column
see
F.
it.
It says column B times column E, right?
Okay, thank you.
Mm-hmm. So this is what is meant by duration. It's the weighted average of the each year, right? Weighted average of each year weighted by their present value of coupon payments in each year, right? The weight is basically weight of each coupon payment out of the total value of the bond. So the interesting thing is, if there is no coupon payment, right? If there is no coupon payment, in other words, in case of zero coupon, there is no difference between duration and maturity, right? There's no difference between. So in zero coupon, right? Duration is maturity. Maturity is duration. So we can also do the same thing. We can figure out. We'll do. Of course, it's gonna be zero because if you 1 plus, yeah, 1 plus, and I mean you discount zero, it will be zero. But we'll just see. Replicate it and to find out. Of course, it's going to be zero, right? And only the present value of the par value, it will have some positive number, right? The present value. And then, of course, what happened here? And then, of course, auto sum. And then we'll do exactly the same. This out of this. And drag it down. All right, didn't I do the auto sum? I didn't auto sum, right? Okay. I'll do it later. And then if you do the same, right? If you weight each year by their weight, okay? So therefore, and I'm gonna do, okay. I'll just copy and drag it all the way down. See, so basically, duration of the zero coupon bond, the same thing as the maturity because there's no coupon payment, right? In other words, there's no cash flow in the earlier time, right? In the earlier time periods. So nothing to, no weight is given to the earlier periods, right? So obviously there should be no difference between maturity and the duration. So now, yeah, that's just, like easy understanding or simple, quick look at the duration. But actually, duration has more. Um, duration has more implication. Uh, so obviously, the shorter the duration, this is the takeaway. The shorter the duration, the better it is. I mean, from the investor's perspective, from the bondholder's perspective, if you get most of your money, most of your cash flow early on, that's better. The sooner you get most of your money back, the better it is, right? The shorter the shorter the duration, the better it is. Of course, if you have a 30-year bond, duration of such a bond cannot be like 3 years. Duration will be something like 20 years or something, 20 something, right? But still, if you get most of your payments, most of your cash flow from the bond, 30-year bond, by year 21, that will be a wonderful thing, right? All righty. So the reason duration is important, right? Let me put it. So let's think about it. Also, we know very well that this is a compact illustration of what Macaulay theorem. Five theorems. I mean, there are 5 theorems in Macaulay theorems. This is a sort of like a compact illustration. So we all know there is an inverse relationship between the bond price and the yield or the interest rate. The yield is a prevailing market rate, right? And if you remember, yield is the rate that makes the left-hand side of the bond valuation equation equal to the right-hand side. There's only one number that can satisfy that. Meaning, the market price is given. Market price is given because that's the price that it's, the bond is selling for in the market. But then there can be only one number, one discount rate that can make the right-hand side. What is the right-hand side? Right-hand side is the present values of all the future cash flows, right? All the coupon payments, right? Present values of all the payments, right? One by one, right? For that right-hand side to be equal to the market price of the bond, there can be only one number, right? And I've been telling you that's why the wording is that the bond is priced to yield something, right? The bond is priced to yield something. That means market price is something that will make that will have only one particular number as discount rate, right? That will make the right-hand side equal to the left-hand side. And then the bond price is, roughly, there's an inverse relationship, right? Inverse relationship means, the higher, the lower the, that's common sense. The lower the discount rate, the higher the present value, isn't it right? The lower the discount rate, the higher the present value, and the higher the discount rate, the lower the present value. I mean, that is what's meant by inverse relationship, right? But if the reality is the inverse relationship is not a straight line, think about it. If the inverse relationship is a straight line like this, the slope will be the same everywhere. It will be just this, it's a straight line. So the slope is the same everywhere throughout this straight line, right? So if this is, something like if the slope is 0.5 and it's a negative slope, right? Meaning, what does that mean? If the interest rate goes up by 1%, right? The price will drop by 0.5%, right? The price will drop by 0.5%, right? That's what it means. If the right, interest rate goes up by 1%, right? And that's a negative relationship because when y goes up, right? When this goes up, this will go down, and vice versa. When this goes down, this will go up, right?
Professor,
Yeah,
isn't bond yield, shouldn't it go down in dollars?
yeah.
I'm sorry, I'm just asking.
What?
I'm just asking, bond yield, is that axis in dollars or is it in percent?
Oh, it's in dollars. Of course, it's in dollars. But what I'm saying is, if the interest rate goes up by 1%, right? And suppose this was, let's say, if this was, the arrow should be like this. If this was 950, if this was 950, right? The price that has changed, right? It will be 5% less than this. In other words, this will be 950 times 1 minus 0.05. Okay? That's what I'm saying. The price will drop by 5%. Right? Does that make sense?
Yeah, thank you. I thought it was going to go down by 50 cents.
Yeah, I mean, if the price was previously, $1,000, right? If the price was previously $1,000, it will go down by, what's 5% of that? $50 then, right? It should go down by $50, right?
All right, thank you.
Mm-hmm. But again, that is a simplified picture, but the reality is more not like that. Reality is more like a curve, not a straight line. So I should, I guess. So let me, okay, instead of erasing this, let me draw this again. It's taking so much time. So the reality is, of course, bond is in dollars, right? what I'm saying is the reality is more like this. Okay, or rather, yeah. It's, it's convex, right? It's a convex curve, convex to the origin, right? So in reality, you cannot say if the price, if the interest rate goes up by 1%, the price will drop by 0.5% through and through. No, it's not going to be like that. Of course, we can approximate it, but the reality is that the slope is not the same through and through, right? The slope. So the slope is getting flatter, steeper at the lower part of the spectrum of the interest rate, lower area, lower segment of the interest rate spectrum. Slope is steeper. And as you go to the higher end of the interest rate, the slope is getting flatter. So for example, somewhere here, if it was, if the slope was 0.5, 0.5, right? Maybe it's, the slope is, it looks more like, our slope is like 0.75 here. And slope maybe, 1.25 here. And the slope may be, almost like 0.1 here. And you understand that as the slope gets steeper, right, the change in the dependent variable is more sensitive. It moves, more, it reacts more sensitively to a small change in the independent variable. And the flatter the slope, right, the responsiveness or sensitivity of the reaction of the dependent variable is more sluggish, right? Or slower, right? As the when there is a change, small change in the dependent variable. In other words, when interest rate changes by 1%, right? That means in this region, right? When where the I think if there's a ruler not coming in, it's not. So suppose interest rate changes 1% here in this area, or the if interest rate changes by 1%, that 1% change in interest rate will result in 1.25% change in the bond price, right? Whereas 1% interest rate change here in this range change will result in like 0.1% change in the right? So this is basically the question of price sensitivity to interest rate change. Think about it. What is this? That means, change in bond price over change in yield, or change in, discount rate, right? So this ratio is literally the slope of this curve, and it's changing, right? It's the slope of this curve, and it represents the sensitivity of the bond price to the interest rate change, right? It's the sensitivity of the bond price to interest rate change, right? So how much, when there is a 1% change in interest rate, how much this will change? And, depending on, in which area or segment of the curve you are, right? It's all different. And this brings you to some, if you, I'm sure most of you have taken microeconomics, right? Because if you're finance majors, and as a finance major, you should have taken macro and micro. And in microeconomics, you have learned a concept called elasticity, right? And what's an elasticity? It's pretty much like this. For example, I'm not going to draw that again. Suppose instead of, instead of B, right? Instead of bond price, suppose this is, this is quantity, right? Suppose this is quantity demanded. Of course, in economics, we put quantity on the horizontal axis. But, the concept is, not that far, right? Different, right? Concept. We can put it on the vertical axis as well. And then this is price. Think about it. We know there's an inverse relationship between price and demand, right? Isn't that right? When the price goes up, demand goes down. Quantity demanded will go down. And if the price goes down, quantity demanded will go up. So roughly there is, this inverse relationship, but it's an approximation, as I said. Always it's an approximation. So in reality, the demand curve, it's called demand curve. They never say demand line, demand curve. Why? Because it's a curve, right? There's a convexity there. It's a curve. So then, elasticity is, how much the quantity demanded changes when the price goes up by 1%, right? So roughly, because we roughly know the relationship is inverse, elasticity is usually, expressed as percentage change in quantity demanded over, let me put it, percentage change in quantity demanded over percentage change in price, right? I mean, it's just because it's the slope, right? Elasticity is basically, slope. In other words, how it's just like, this, but then if we rewrite, what is the percentage change? So let me, what happened? Okay, let's see if I can copy this. Oh, I just copied one. Let me put it here, somewhere in the middle. Okay, so this is elasticity, but what is percentage change? It's basically change in quantity, right, over quantity. And percentage change is percentage change in price is change in price over price, right? But then it can be rewritten as, we know, because multiplying, dividing by a fraction is the same thing as multiplying by the reciprocal. What am I doing? Multiplied by P over change in P, right? And then, which can be, the denominators, they can be swapped, numerators can be swapped, denominators can be swapped, they can either way, right? Because it's the same thing. I mean, you're multiplying, so you can swap each other. So it finally takes the form of change in Q over change in P times P times Q. And that's elasticity, right? And of course here, this Q, because think about it, change in P is what? Change in P is basically a new price. Change in quantity is Q1 minus Q0, right? The old quantity, right? And just the same, change in price is also P1 minus P0. And Q is Q0, right? And also P0, right? And also that's P0. I mean, but we generally don't we consider that assumed. Generally don't state it is Q0 or P0, right? But you have to remember that's actually old quantity, old, the original quantity, original price. Now, this is elasticity. We know, and then actually the sign of the algebraic sign of the elasticity is always negative. This comes out as negative. Why? Because they move in opposite direction, right? We just don't, even if, we ignore that minus sign, even if we ignore that minus sign, but all elasticities are basically negative number, because the direction of change between the both, direction of change is, opposite, right? When we all know, when, if this is negative, right? In other words, when price goes down, quantity goes up, right? So this is, oops, what did I? This is negative, algebraically, but we just don't need to express it as negative, because even if it is, even if we express it as positive number, but we know the direction is the opposite, so we can, if we predict the change in quantity, right, then we know it will be in opposite direction from the change in the price. Okay, but then if you understand this concept of elasticity, you will now you understand the concept of duration is just the same thing as elasticity, right? Now again, we'll put the this is bond price, we'll put it back, right? The labels back. And why is the duration just the same as elasticity? It's the elasticity between bond price and discount rate. Why? Well, because think about it. If we smooth out this curve, it will become a straight line. Smoothing out the curve will inevitably have to be the average of all these different slopes, average of all. So it will be a weighted average, right? It will be a weighted average of these different slopes, and therefore, and what is the duration? Duration is weighted average of years, right? By weighted average of years, weighted by their present values. The present values are here. I mean, but this is not the present value by the years. So the label of the axes are slightly different, but you can sort of equate the concept of weighted average of different slopes to bring it to a smoothed out, right? This is already smooth, but what I'm saying is, if you flatten it, right? So that's why duration can be understood as elasticity. Now, there's more, obviously more to talk about, but it's, 10:33, so this is just about the right time to take a break. So let's take a 10-minute break and reconvene at like 10:45. Okay? All righty. So 10 minutes. All right, we're back. We're back. So let's see. So I was saying that duration is just like the elasticity concept in microeconomics. So we can write. So basically, based on the elasticity formula, we can find the duration. We can redefine duration as, right? Duration is redefined as, duration is basically percentage change in bond price to, it's the ratio between the two. It's basically, percentage change in bond price over percentage change in yield, right? Then, by definition, of course, it's change in bond price over the old bond price. Of course, that's bond price at time zero. I won't repeat that. And then what's happening? Change in yield or interest rate over 1 plus yield. Now, then we can rewrite this. We can rewrite this as change in B over B times 1 plus Y over change in Y. Okay? Well, that's, now again, some people might wonder, why is it, in change in yield, percentage change in yield, isn't it, shouldn't it be like, because it's change in percentage change in yield, wouldn't it be like simply like this? Or shouldn't it be like, 1 plus change in Y over 1 plus Y? Now, actually, first of all, this is wrong. Why? That cannot be. Why? Because, the interest rate is just, something like, a number between 0 and 1, and especially it's not even, 10%. I mean, two digits, it's like, single digit, like, 0 0.08, 0 0.09, 0 0.07, right? 7% interest rate. But, if basically if the price grows, right, the result will be 1 plus y, not just y. The outcome will be 1 plus I, right? Think about it. Previous price times 1 plus y, not just previous price times y, because then it will be just a very small fraction of the previous price. So it wouldn't be like this. You wouldn't write it like. But then why not like this? Why not like? Well, first of all, this one is not right either. First of all, this one is not right either, because it's not that it's not right, but what I'm saying is you can write it like this. This is okay, but the thing is, it was originally, if ever, it's the change in 1 plus. Originally, it should be like change in 1 plus y. But then think about it. 1 is already a constant, right? One is already a constant, and it doesn't apply to 1. It doesn't change. It doesn't change, right? 1 is already a constant. What changes is only y. So the change will apply only to y. And there's no need for writing even 1, because that's not the part that is changing, right? Hence, we got to change in y over 1 plus y. Okay, so this is called Macaulay duration. Macaulay. Okay. Let me move this. Because an American, Macaulay is a Canadian economist, I believe, back in the 1930s or 1950s or 1930s. I mean, I skipped, basically Macaulay theorem, but Macaulay theorem is if you understand, basically if you understand this relationship, right, that that there is an inverse relationship between the bond price and the interest rate, and that relationship is not a straight line but a curvature, right? And that explains, that's pretty much everything about Malkiel's theorem. You can just read it. Malkiel's theorem. Malkiel was a American economist in the 1930s. So actually, it paved the way to duration and convexity theorem. Duration and convexity. So again, this is called Macaulay. Is it 2 C's? I think it is just one. Macaulay. Macaulay duration, right? And why is duration important? As I said, duration is an approximation. I mean, it's the slope. It's the slope, but the average slope, right? But the average slope. Again, because on a curve, slope varies everywhere, right? Slope varies everywhere on a curve. So we need to we need an average. So if we average it out, it will be approximated as some straight line. That way, it's a rough measure. It's not a precise measure, but a rough measure of predicting the bond price change when there is a interest rate change. In other words, by having duration, right? Since duration is the slope, average slope, and with the slope, think about it. With if this is duration, right? Then it's not like this, but right? It will give us, power to predict. Why? Because think about it. When there is a suppose interest rate change is predictable, and it is. Indeed, I've been telling you over and over. Federal Reserve always releases the guidance after the FOMC meeting, right? So there is this communication with the market. Always, they are they have this press conference, where they release their where release their opinion about the economy, and then what they will do about the interest rate. So if they say we're going to raise interest rate, by 6 times by the end of this year, and each time, by quarter percentage point, right? Quarter percentage point. Then we know, oh, next year, if interest rate goes up by 4 times, that's going to be 1% increase. If interest rate goes up by 6 times, it's going to be 1.5%. You know that the interest rate will be 1.5% higher next year. I mean, overall, even in the bond market, basically all in every bond class, right? AAA, AA, single A, in every class, risk class, the interest rate will be higher by 1.5% a year from now. Let's say it's going to go up by 1%. I mean, if we know it's going to go up by 1%, right? What should I use? Maybe this. So currently, if the current market price, current price of the bond is something like this, and currently the whatever the rate is, this is the Y0. Currently the rate is Y0, and 1 year later, the interest rate will go down by 1%, which will be the new. Oh, go up. I'm sorry, go up. Yeah. If the rate is going to go up by 1% next year, the bond price will be lower. But, by how much lower will it be? How much lower will it be? Right? It's going to, so currently price is here. that the price will fall, right, next year. So then we can, we can take an action before it happens, and then because duration is by definition, think about it. Because by definition, duration is percentage change in, which is, B over B over Y over 1 plus Y. Okay, so what we want to know is, okay, what's going to be the percentage change, in other words, in the bond price? Then think about it. Solving this equation for this, right? Now the equation is solved for D, but if we solve this equation for this, now we're going to solve this equation for this, the percentage change in bond price. What do you need to do? All you need to do is D times, right? All you need to do is this, right? And you know what this is going to, everything you, currently the interest rate, we know the current interest. This thing, we know, whatever it may be, call this Y0, right? And we know what this is going to be. It's going to go up by 1%, right? Change will be positive 1%. In other words, it's going to go up. And we know what this is. We know the duration, right? The slope, if we have found it. And then we know this is a negative number, right? And then it doesn't, we don't have, that means, this is the percentage change, and this will come out as negative too, right? If so if this comes out as 5%, whatever, and then from the current bond price, from B0, you subtract that, you'll find expected bond price 1 year from now, right? So this is basically, what, let's go to the slide. This is what the slide is, saying. Okay. This is percentage change in the bond price, right? Is duration times, we know this already, right? And duration is a negative number by its own mathematical construct, it's a negative number. When interest rate changes, percentage change in bond price is proportional to the duration. Change in bond price can be related to the change in yield. So here's an example, but so let's take a look at this example. Maturity is 30 years, right? Coupon rate is 8%, paid annually. Yield to maturity, 9%. Yield is 9%. Currently, the bond price is 897. Duration is 11.37. So although it's a 30-year bond, effectively, you'll get all your, you'll recover most of your cash flow in about 12 years or 11 years, right? If the yield to maturity yield goes up to 9.1%, what will be the change in the bond price? Right? What's going to be the change in bond price? So let's write it out. Let's do this example. So here, maturity 30 years, right? Duration 11 point what? 11.37. Bond price now 89 something, right? 800. What was that? 97.26. 9726. And currently, yield is 9%, and change in yield is going to be 0.1%, right? And the question is, what's going to be the new bond price? Okay. The old bond price. I think the question was rather than this. I mean, that's ultimately, but the question was what's going to be this, right? Well, we will know that. So think about it. We know that the from here, right? I already wrote it out. Percentage change in bond price is duration times, right? Change in yield over 1 plus yield, right? So we apply that, right? So basically, this is percentage change in bond price is 11.37 times 0.001 over 1.09, right? And of course, the change will be negative, right? Because even though I put, a positive number here, even though this is positive, we know this will be there will be a negative change in the bond price, and we know B is that. So if you do this, right, simply using the calculator, $11.37 times 0.001 divided by 1.09, it's going to come to 0.01043. So let's say 0.1043. This comes to 0.1043. Am I right? Oh, 0.01043. I'm sorry. 0.01043. So 1.01. Yeah, what am I? I'm reading something and I'm saying something else. Oh no, 0.10, right? 0.10. I'm sorry, 0.10. Okay, 0.1043. And then since then the change in bond will be, right? Change in the bond price will be B times this. And B is what? 897.26. So I'm gonna multiply 897.26 is that right? 897.26. There you go. 82317. Actually, that's not the change. That looks like a new bond price. Something is not quite right. Where did I go wrong? Oh, divided by y. I thought I multiplied. So again, so let me do this. 897.26 times, right? And what was the 11.37 times 0.001 divided by 1.09. There you go. You get something like 9.36, but that should be negative. Why? Because when interest rate goes up, the price must go down. There is an inverse relationship. Change in bond price. If you don't enter duration as negative, it will naturally come out as positive. But that means that's the downward change. 9.36 is how much it will drop. If you enter it as negative, it will come out as negative, of course. So the change is negative, right? So this way you can have a prediction, right? How the bond price will change. Again, but this is an approximation. It's not it's gonna work well if the think about it. It's gonna work well if the curvature is not as pronounced as this. If the curve is relatively flat, if the curve is relatively flatter, then it will. If the curve is more like a straight line, similar to this, if the curve is like okay, let me. If the shape of the curve is more like this, yeah, it will do a good job, right? Duration will do a good job. But if the curve is, if it has more curvature, like this, then the farther away from the flat origin, I mean, let's say, um, uh, if the slope is 1, let's say if the slope is, duration is 1, if the duration is 1, and whichever is closer to the, let's say, actual duration, if the duration, in other words, the slope of this straight line is, let's say, something like 0.9, 0.9, then when the in this range, right, where in the range where the slope is something like this, closer to the 0.9, then it will do a good job. But when it is, completely far away like this, it's not going to do a good job. It's not, it's going to be very inaccurate. So that's why we need convexity. But we're going to come back to convexity later. But for now, okay. So we roughly understand the concept of duration, and then we can even do this on Excel. I mean, basically, all we need is put these variables and then put these inputs, and then in the cell, all we need to do is put in these formula there, and then it's going to automatically calculate the change in the bond price. Okay. Next thing is modified duration. Modified duration, right? We know what Macaulay duration is now. But then so let's see. So here, the Macaulay duration is basically the equals, change in B over B times, right? Change in Y over 1 plus 1 plus Y. But what if we multiply both sides, no, actually, what am I doing? It's divided, so it should be right. It's divided. So it's actually, you know, change in B over B times 1 plus Y over change in Y, right? That's Macaulay Duration. But what if we multiply basically, you know, 1 over Y here to the left-hand side? Multiply 1 over Y to the left-hand side, to the Macaulay duration. So modified duration is simply Macaulay duration divided by 1 plus Y. Then, we will have in the right-hand side, we will have we'll have only this. Why? Because, you know, 1 plus Y and 1 plus Y will cancel out, right? This one plus Y, you do the same thing here. So that 1 plus Y will cancel out with this. This is really annoying. It will cancel out. So we end up like this. Okay. Okay. And this is called, you know, modified duration, or D star. That's not multiplication, that's star, right? This modified duration. And if you use modified duration, then predicting percentage change in bond price, predicting the percentage change in bond will be simpler, because if you want to predict percentage change in the bond price, it's simply going to be modified duration times change in interest rate, right? Well, just mathematically, you know, it's you have to divide because, you know, it's x times y equals, I mean, to do this, you will have to divide. You'll need to divide modified duration by this. And dividing by a fraction is the same thing as multiplying by the reciprocal of the fraction. Then we come to this. Well, it doesn't really matter. I mean, you know, there will be a slight difference between the modified duration and the Macaulay duration, but it doesn't, you know, it doesn't really make that much difference. It's not that, you know, it doesn't really matter. Anyway, duration itself is basically an approximation of that curvature into a straight line. So as I told you, as you go to the more, if the curve is more bowed out, or bowed in, or bowed out, whatever you call it, the curvature is more quite bowed out or bowed in, right? if the curve is very flat, relatively very flat, the approximation will work well. But if the curve is bowed out, right? Anyway, as you go to the outer edges or the outer areas, it's gonna be duration isn't gonna do a very precise job, right? It's not gonna be very accurate. So we need, to fix that, that inaccuracy. We need to bring in convexity, but that's going to be later. But by now you should all understand what duration is, and we've done this. Oh, we didn't do this. I believe we didn't do this. So this is a built-in command. Excel has duration and modified duration already built in, and then we can use that command. I believe it isn't there, but okay. I want you to do this. I mean, you need to open. You can the file that you have used, right? Open a at the bottom. You see, you have only this. So open another worksheet, right? Open another worksheet. And in that worksheet, just build this. I mean, copy first. Copy this. You have worked this out. So copy this and paste it there. Okay. Copy that and paste it there. Okay. Did you copy it? Everyone, anyone there? Hello?
Yes, Professor.
Yeah.
We copy.
Okay. Okay. At least 3 people are there, 3 or 4. So are
Yes,
you?
we're here.
Yeah. Okay. Good. So you heard me.
Yeah, I'm here,
huh?
Professor.
I told you to copy this, right? First, open a new sheet, right? Open a
Hi,
new
Professor.
worksheet.
Yeah, I'm here. I'm sorry.
Yeah, open a new worksheet, right? By adding, clicking on this button, and it's going to open a new worksheet. And then into that new worksheet, copy this table, paste it into that. Okay, so everyone is done. Everyone has copied that in. And once you have copied that in there, then build this table. Build this table. It shouldn't take that long, right? In column H, settlement date, maturity date, coupon rate, yield, coupons per year, number of coupons per year, and then those are the inputs, labels first, and then outputs, Macaulay duration and modified duration, right? So here, put the in column column I, settlement date, right? Enter it as like this, January 2nd, 2019, and then maturity date will be 3 years later. So what I did was, I did 3 years. I2 times 3 times 365 plus 1. It doesn't matter, so it will become, January 2nd of 2022, or you can just, manually enter January 1/2/2022. Coupon rate 8%, yield 10%, coupons per year 1. Okay, then in the outputs, so let's do this. Macaulay duration I told you, Excel has, those variables. Open function and go to financial, okay, financial category, and then scroll down to duration. You will see, yeah, there, duration, okay, and give it what it's asking for. Settlement date, there you go. Maturity, there you go. Coupon rate, there you go. Yield, there you go. This is coupon frequency, right? We assumed annual coupon, so 1. You don't have to put any basis. Hit OK. You'll get Macaulay duration. What if it is modified duration? It's just, this divided by 1 plus y. And we can verify that later. So we'll enter.
Sorry,
Again,
Professor, divided by what? The modified
no,
duration
later.
is the.
Yeah, modified duration is Macaulay duration divided by 1 plus y. Okay?
Oh, okay.
So
1
we'll
plus y.
verify.
Okay.
No, don't
Yeah,
do
yeah.
it now. Don't
No,
do
no,
it
no.
now. We'll verify it later. We'll verify
Yes.
it later. That was all explained already in the as I was explaining this.
Yeah, in your
right?
notes. Yes, yes, yes.
Right?
Yeah. I was
Macaulay
I
duration
just
divided by 1
yeah.
plus 1. Yeah.
I just didn't get you when you were saying it there.
So
Sorry.
now let's go to modified duration. So M duration, right? There's modified duration. Hit OK. And, input settlement. And then maturity. Coupon rate. Yield. Frequency, 1. There you go. You don't have to do basis. Hit OK. You get 2.52. Okay. Again, we can verify this by we divide this by 1 plus y, and then yeah, that's exactly Macaulay duration. It's like Macaulay duration is like discounting. Modified duration is like discounting Macaulay duration 1 year by okay. So modified duration verified. Okay. All right. All righty. So it's 11:34. So this is once again about good time to take a break. So let's take a 10-minute break, and we'll come back, reconvene at like 11:45. Okay. Okay. 10.
Hello, Professor. Professor.
All right, we're back. We're back. Um,
Professor.
yeah, Robert. Was it
Yeah.
Robert?
Yeah. Yes, it's me. First, I have a
Yeah,
family
yeah.
emergency. I'm gonna have to leave early.
Okay, okay. Yeah.
Just wanted to make sure that you knew first.
All right, all right. Yeah, you can. I mean, if you've been, if you have to, you may be excused. Um,
Thank you.
you're welcome. All righty. And so we're gonna have to. Okay, so here, back here, So previously, this had only like 3 digits, and then at the time, and I
Uh,
expanded it.
Professor.
I ex
Sorry.
Yeah.
Is there anything due for like, or do we have to do anything before class is over, or?
No, no, no. Nothing further before the class is over. But
All
just
right.
make sure. Yeah. I
Okay.
mean,
Thank you.
there's no exercise. I mean, like this. Yeah, we're moving on to a new concept, new topic called immunization. But um, so
Thank you.
you're welcome. You might say, if it was like this, and you're saying that isn't quite the same. It's the same thing. It's just a matter of, here I used only 2 decimal places, but if you expand the decimals, right? If you increase the decimals, that was exactly, it was just rounded, and we come to the same, thing, right? All right. So that brings us to the next topic. So basically, you know, the beginning of this chapter was basically Malkiel's bond pricing relationship, 1962, and it is all basically, you know, it is all about the curvature. I mean, the relationship between the interest rate and the bond price depends on the curvature, and there's an inverse relationship. First of all, bond and interest rates are inverse related, and you know, increase in the when that means, you know, increase in yield results in the change in bond price, which is less than change in bond price due to decrease in yield of equal magnitude. What does that mean? When the yield goes down, interest rate goes down by 1%, although it is the same 1%, the impact is not the same, right? When it goes down, when the rate goes down, the change in the bond price is greater. The magnitude of the change is greater than when rate goes up. So you can look at, you know, like the curve D, right? It's the same. Think about it. This is not the interest rate, but change in interest rate. Change in interest rate, right? So 1% drop, 2% drop. I mean, from zero, no change. If it drops by 4%, 4 percentage point, then look at the from where's the price? When there was no change, the price was, you know, of course, there's no change in the price because there's no change in interest rate, but it drops by 4%. The price changes by like 100 percentage point. Huge, you know, difference, 100 percentage point. I mean, not percentage point, but percentage change. So percentage change. And when it goes up by 4%, 4 percentage point, right? Same magnitude. How much does it drop? It only drops by about 25%. Price drops only by 25%. So what a big difference. And here's something, this may, hope this isn't, you know, but just to clarify, because some people might get confused, the horizontal axis is percentage point, and the vertical axis is percentage. What's the difference? What's the difference? This is some people don't understand this, but you know that it's like this. If you suppose your stock price was, suppose the stock price was $100, right? Price of the stock. That was P0. And P1, let's say the price dropped to $50. Okay. Then what's the change? Of course, we know the change is 50%. I mean, it dropped by 50%, right? But so for this to go back up, right? I mean, your stock price dropped 50%, but for it to go back up, how much should be the change? I mean, how much should it go, what percentage right? What percentage should it rise? By what percentage should it rise? Anyone? Are you there? Anyone there?
Yes, it will be
How much should it increase?
by 50%. If you're doing like the increase of the 50%, should increase by
No,
50%.
no. From $50 to $100, the change is 100%.
Yeah,
Isn't that right?
yeah, yeah,
You have to double, right?
yeah. You have to
So
double it.
yeah, but then percentage point, right? It's 50 percentage point, right? The difference is 50 percentage points. In other words, from 100% to from 100% to 50%, and then back to 100%, the change is 50 percentage point, right? So that's the difference. Percentage point and percentage. There's a reason why there are these two different terms, right? Two different terms, percentage and percentage point. Okay. Um, think about it. From $50 to go back up to $100, you have to double. The price must double, right? Double means 100%, right? But by percentage point, it's still 50 percentage point. Does that make sense? You're simply counting the from 100% to 50%. So back to 100% by percentage point is 50 percentage point. It has to regain 50 percentage point, but actually that means it will it has to double, right? So that's why you think when the stock lost 20%, you think, oh, it just needs to gain back 20%. No, actually, it's easy to drop 20%, right? But regaining 20 percentage point takes more effort than it's not easy. It's easier to drop 20%, but then not easier to gain. So think about it. If it dropped 20%, then currently it's 80%, right, of where it was originally, right? So from 80%, you have to getting back 20 percentage point is like 2/4, so it's like 25%. It has to grow 25%, right? Make sense? All right. I'm sure nobody's answering, but I guess that you
Yes,
I,
sir.
understand
but
that.
Exactly.
I don't get it, Professor. So, is it like I know the concept of BPS, like basic points, but that's completely different. Now, that's what
Yeah.
like what you're explaining.
Basis point is not basis point is just one
Like
hundredth of
100 of
one hundredth.
a percent. Yeah, but that's completely different as like 50 percentage points. Like that concept that you are explaining, right?
Yeah. Again, I just used let's say the let's say the price is $100, and let's say uh, it dropped to $80, right? Of course, the drop is 20%, right? It's a 20% drop as well as 20 percentage point drop. Uh, but for this $80 to go back up to $100, right, to regain its original position, right, original price level, it will have to grow by 25%, right? In other words, 25%, but 20 percentage point. Okay, why? Think about it. It has to gain $20. $20 is what? 25% of $80, right? Isn't that right? $20 is 25%, 1/4 of $80. So going back, to regain $100 price level, $80 must grow by 25%, right? But you can call it I mean, if this is 100%, 80%, it's 20 percentage point, right? Based on $100, right? It's 20 percentage point, but based on $80, it's going to have to grow by 25%. All right. I hope that explains the difference between the percentage and percentage point. So I needed to explain that because the horizontal axis is percentage points, right? But the vertical axis is, percentage change, right? All right. So then there is, what determines the duration? It is all related to the Macaulay theorem. So I want you to go back to Macaulay. And this formula, this is called close-ended formula, but it's another way of calculating duration. It looks quite complicated, but I will show you later when it's time. It's actually it could be a little more simplified. So here's the so Macaulay had 5 rules, 5 theorem, but what determines duration? There are 6 factors that will affect the duration. Excuse me. We know zero coupon bond, duration and the maturity is the same. Maturity, holding maturity and yield constant, duration and interest rate sensitivity of price is higher when coupon is lower. And this is related to Malkiel's, theorem number 5. And common sense tells you the smaller the coupon payment, right? The present value is more sensitive, right? Price moves, reacts more sensitively to the interest rate change. And so this is something you can read and also read up. And also it is, holding coupon rate constant, price sensitivity, price sensitivity of the interest, right? Or interest rate sensitivity of price generally increases with maturity. So this is all explained, duration is also a function of maturity because zero coupon bond, no difference between duration and maturity. Now, maturity and duration both, 30 years, but when rule number 1, that's there's no difference between duration and maturity in zero coupon. Number 2, what was number 2? Holding the maturity constant. The coupon rate will determine, right? It is, if the coupon rate is high, 15% coupon rate, right? Duration is at best 7.67 years. Such a good coupon. Duration, maturity is 30 years, but the duration is pretty much, like this. And if the coupon rate is low, if the coupon, 3% coupon, right? Duration is much higher, almost like 13 years. That's rule number 2. Rule number 3, I didn't find rule number 3 here, but rule number 4 is what? If yield to maturity is high, yield is high, also the duration will be high, because obviously if you discount with higher coupon rate, if you discount, I mean with a lower I'm sorry, with the lower yield, lower discount rate, higher coupon rate and lower discount rate, you'll have what is this? High coupon rate. I mean low coupon rate, high yield. High coupon rate but low yield. Because cash flows are discounted more, right? And the ones that are in further into the future, right? The cash coupon payments further into the future will get discounted a lot. And so most of the weight is in the earlier coupon payments, right? Earlier coupon payments, although it is discounted by high discount rate, but still it's just 1.15 squared. And think about it. Earlier, although it's smaller coupon payment, it's not really cutting deep, because it's not like 1.15 raised to 20 or 30, right? But the ones like coupon payments after year, think about after year 15, because it is so deeply discounted, right? It doesn't affect the price of the bond that much. So pretty much the duration cuts out somewhere around year 10. But if discount rate, even at high coupon rate, lower discount rate, the farther, what should I say, far out, the coupon payments in the far out future will still factor into the bond valuation. So duration will be higher. So that's rule number 4, right? So that's something you can read up, right? Duration of annual coupon bonds, initial bond yield 6%. That explains rule number 3. Rule number 3 was basically what? Holding coupon constant duration and interest rate sensitivity generally increases with maturity. So duration always increases with maturity for bonds selling or above par value, selling at or above par value. So premium bonds or a bond selling for $1,000, duration, of course, duration increases. Duration increases with as maturity increases, and even without a mathematical proof, intuitively you can. But intuition, you cannot always rely on intuition. We have to prove it. So, well, fine. Holding, so just if the coupon rate is 4%, the longer the maturity, the longer the duration, right? 6%, holding coupon rate at 6%, the longer the maturity. There is a, right, positive correlation, right? Oh, one more thing. I almost forgot to mention perpetuity, right? Duration of a level perpetuity is what? Like, preferred stock that pays just constant dividend, same dividend over and over. No change in dividend. And just like that, a bond that pays just bond is basically a perpetuity, but I shouldn't say perpetuity. Bond is an annuity. Perpetuity is an annuity that goes on forever. So if there's a, I told you, bond pays constant coupon, constant interest, and preferred stocks pay constant dividend. So preferred stock is like an annuity, so it's like a bond, but the difference is that preferred stock is a perpetuity. It pays constant dividend forever, indefinitely. So if we have a bond that's like preferred stock that pays, it has no maturity. How can a bond have no maturity? Well, all the bonds, but it can be, there can be some bond that never pay. If you are borrowing money with no prospect of paying back the principal anytime soon, but instead you pay, half the coupon, half the interest rate forever. I mean, it's a winning game for the lender, but obviously at some point it's a losing game for the borrower, because when you have paid already enough interest to break even, right? Break even with the principal and the interest up to that point, then paying any interest beyond that point is a losing strategy for you. But let's say even if, in case of bond, there is no, there is hardly any perpetuity, but preferred stock is treated almost like a debt because it pays dividend forever. So it's like, a coupon bond that pays, constant coupon forever. But how do you then how do you find the duration of a perpetuity? It's simply 1 + y over y. That's the duration for perpetuity. So that brings us to, I was hoping to get into immunization today, but it's almost, I don't think we can get into immunization because, but let me quickly, summarize what it means. Immunization sounds like, a flu shot or COVID-19, vaccine. Yeah, Same idea. Why? So suppose you have debt obligation like bonds, right? You have liabilities, right? Bonds, right? You have $1 million in bond to pay, right? That's the bond you sold. But then and if the maturity is like 10 years, right? 10 years is a long time, and there can be interest rate fluctuations. And you understand when interest rate fluctuates, then you have two types of risks associated with that inflation fluctuation, right? Interest rate fluctuation. One, interest rate risk. The other one, reinvestment rate risk. Now, interest rate risk is also called maturity risk or price risk. Why? The price fluctuates. If interest rate goes up, price goes down. If interest rate goes down, price goes up. So think about it. You will have to, in year 10, at the end of year 10, you will have to pay back. You'll have to pay back $1 million, right? Until then, you pay all the interest, right? For 10 years, you pay interest. But so at the end of year 10, you have to cough up $1 million. But suppose you were, how do you pay back $1 million? It has to come out of the come out of the assets that you have, right? So if by year 10, if the assets that you have, and these assets, of course, with $1 million that you borrowed at time zero, you would put that $1 million into some investment instrument, and by year 10, this investment instrument would have to grow to $1 million. And if it grows to $1 million, then you have no problem. You will have matching, your debt obligation and your assets will be matching. So you have no problem. But sometimes this may not be the case because of interest rate. If interest rate goes down or goes up, the present value, especially if interest rate goes up, the present value of this asset may be smaller than $1 million. Then you will have a problem, right? At the end of year 10, you should cough up, you should come up with, this $1 million, but your assets are worth less than $1 million. You're in trouble. So to prevent that kind of imbalance between assets and liabilities, you immunize your assets to match your debt obligation. That way, you won't have to worry about that imbalance. So how do you immunize that? It's basically duration matching. If you match the duration, then it will be that problem will be solved. So that's a brief illustration of a brief explanation of what immunization is. But we're gonna have to talk about it in the next class. We're out of time. Any questions so far? Any questions? Hmm? Any questions?
No questions, Professor.
All right, all right. All right, then, have a great
Yeah,
afternoon,
all
everyone.
good. Thank you, Professor. Have a great afternoon.
All right,
All right,
take
Professor.
care.
Thank you,
Bye-bye.
Professor.
All right, take care.
Sure, Professor. Have a good day.
Take care. I will see you guys, next Saturday. Okay, stop recording.